Welcome back. Well, last lesson I went over that most important aspect of integration, integral f dash of x over f of x dx equal to ln f of x plus c. Remember when I gave you the integration formula in the handout, I have put some formula in red and I haven't said anything. Those red, sometimes you might be asked to prove them. If you're not asked to prove, if you can remember them, please go ahead. Otherwise, you might be asked to prove, as I will show you. Show that. Number one, integral tan x dx equal to ln sec x plus c. Sometimes they ask you to show it. Well, that's integral sin x over cos x dx. It's a rational expression. What do? You don't compare powers when it is sin and cos. You look at the derivative of the denominator. Remember I told you, always look at the derivative of the denominator. I'm sorry, I'm just setting the stopwatch. Okay. The derivative of the denominator cos is minus sign. So for your reference, I'll write it here. I don't need it, but to make you understand, I'm writing this. I have a sign, so I'll write as minus integral minus sin x over cos x dx. The numerator is f dash of x, denominator is f of x. Answer is ln. So it is minus ln sin x. Oh, sorry, f of x is cos x. Rules of logarithm. I can write it as ln of cos x power minus 1, which is ln of 1 over cos x, which is ln sec x. If you're not asked to prove, you can quote the formula and use it. But if you're asked to prove, that is how you prove it. Let me have a sip of water. Again, my throat is going dry. Sorry, hope you don't mind. Similarly, I leave it to you to prove the other formula. Integral cot x equal to ln sin x. I will prove this. Show that integral sec x dx equal to ln sec x plus tan x plus c. Whoops. You might be asked to prove this. Alright? I told you before, you cannot multiply and divide by a constant, correct? Isn't it? Outside the integral. But within the integral, as long as you're simplifying, you can multiply and divide by a variable. Sorry, what am I saying? As I told you before, you can only multiply by a constant inside and outside. But inside you can multiply by a variable. So I'll write this as I'll multiply by sec x plus tan x and then I divide by sec x plus tan x. Why? Because I want the answer sec x plus tan x and it's not there. Okay? Why did I do it? Suppose I open the brackets, can I write it as sec x tan x plus sec squared x over sec x plus tan x. That's the beauty of math, you see. Why am I stressing that the most important formula? What do you get when you differentiate sec x? Sec x tan x. There's a plus, there's a plus. What do you get when you differentiate tan x? Sec squared x. So therefore, the numerator is exact derivative of the denominator. So therefore, it is ln sec x plus tan x plus. Yeah? Good. You might have seen this formula. The next one is quite interesting. This is where, it could come as an A-level question. Number 4, show that is already there. Integral cosec x dx equal to ln tan half x plus c. Or ln of cosec x minus cot x plus c. You must show both. Yeah? This is where trigonometry you need to know very well, as I will show you here. Same trick. I want what do you get when you differentiate cosec x? You multiply by cosec x plus cot x and divide by cosec x plus cot x. What do I get here? I get cosec x cot x plus cosec squared x over cosec x plus cot x dx. Correct? Yeah. What do you get when you differentiate cosec x? Minus cosec x cot x. What do you get when you differentiate cot x? Minus cosec squared x. I have cosec x cot x. I have cosec squared x. I don't have a minus. So what I'll do is, I'll say it's minus integral minus cosec x cot x minus cosec squared x over cosec x plus cot x. Yeah. The numerator is the exact derivative of the denominator. So the answer is minus ln cosec x plus cot x. Of course, plus c. But I don't want, there is no minus. The minus from outside has gone inside. So you can't take the minus inside. It's not your grandfather's property. So what I do is, can I write this as ln of 1 over cosec x plus cot x? Why? It is ln of that power minus 1. So I can do 1 over. So far so good. At this stage, I multiply by cosec x minus cot x. I divide by cosec x minus cot x. Why am I doing it? Because I want cosec x minus cot x. I am using trigonometric identity. So let me rub this off. So what does that become? ln of cosec x minus cot x over cosec squared x minus cot squared x. A plus b times a minus b is a squared minus b squared. Identities tell you that is 1. So it is ln of cosec x minus cot x plus c. The formula book has that formula and the next formula. Now I have to show this stupid thing is also ln tan half x. Go back to trig identities. Let's take cosec x minus cot x is 1 over sin x minus cos x over sin x, which is 1 minus cos x over sin x. Yeah. I want to get tan. That means in the numerator I want sine, in the denominator I want cos. And I want a half angle. Remember, cos 2a is 1 minus 2 sine squared a. Trigonometry is going to haunt you. If you're not good at trigonometry, you will get stuck every time there's a trick question in integration or differentiation. So get trigonometry thoroughly into your brains. So cos x is 1 minus 2 sine squared half x. Sin 2a is 2 sin a cos a. So sin x, I'm tired today, equal to 2 sin half x cos half x. So it becomes 1 minus 2 sin squared half x over 2 sin half x cos half x. 1 and 1 cancels, so I get 2 sin squared half x over 2 sin half x cos half x. A sine squared goes with a sine and the 2 goes, I get tan half x. Right? That is how you show the 4 standard formula. I'm going to take up a typical A-level examination question. Number 5. There's no show that. Resolve 1 over x squared minus 1 into partial fractions. Is it 1 over x squared minus 1 or 1 over 1 minus x squared? Wait, let me see if I can figure out. Okay, yeah, okay. So let's do that. Part A. Part B, find integral 1 over e power x minus e power minus x dx. Now, using the substitution, t equal to e power x. Where's the link between? Okay, let's do part A first. So I will then talk to you. I said something before. Let's do it here. So part A, 1 over x minus 1 times x plus 1 equal to a over x minus 1 plus b over x plus 1. So 1 equal to a times x plus 1 plus b times x minus 1. I don't want to teach you cover up rule. It's easier, but it's confusing. It's basically what I'm doing is the same thing. So put x as 1, a equals half. Put x as minus 1, b equals minus half. Is it? Yeah. So therefore, the answer is half over x plus 1 minus half over x minus 1. Yeah. Where is the link between that and this is the question. Let's do part B. T is equal, how do you substitution? You're given. So find dt by dx is e power x. So dx equal to dt over e power x, which is dt over t. So it becomes integral 1 over t minus 1 over t times dt over t. Are you seeing the link? Okay. That's integral 1 over t squared minus 1 dt. Now do you see the link? Remember I told you, if you are part A and part B, in 99% of the cases, part B has got something to do with part A. 1 over t squared minus 1, 1 over x squared minus 1. So that is half integral 1 over t minus 1 minus 1 over t plus 1 dt. So that's half. When you differentiate t minus 1, I get 1. So the numerator is 1. So half of ln t minus 1 minus ln t plus 1, which is half ln t minus 1 over t plus 1. Oops. This was plus, that was minus. This was plus, that was minus. This was plus, that was minus. I'm sorry. So that is half ln e power x plus 1 over e power x minus 1 plus. You see, when you did this and when you looked at it, you never thought there will be a link between that and this. It's so wonderful, you know. You just do this, do some magic, it comes and links together and you're able to integrate. So integration is more imaginative than differentiation. Differentiation, you know, standard formula, just apply it. Onion rule and chain rule and quotient rule and product rule, function of a function, blah, blah, blah. Whereas in integration, each question has its own method. So that's 17 minutes. So to recollect, this is the logic in integration. When you see a question, check if you can integrate directly. That's if the derivative is a constant. No. Can you use substitution? Okay. No. When is it a fraction? Okay. If it is a fraction, is it a proper fraction? Yes. Is the numerator derivative denominator? Yes. No. Can you do partial fractions? Yes. Do partial fractions and integrate. Yeah. So far I have done that. Then I've got rules for trigonometric functions. Then we do integration by parts. That will be another 6-7 lessons minimum. Okay. So I will see you next time when I start on the maybe I might do a couple of more examples on this. I'm not too sure. It's very difficult to make up questions in integration. We'll see. Otherwise, I'll start with integrating trigonometric functions. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.